Hello everyone, you are welcome to this class. So in this class, we continue from where we stopped in our last video. So today we start with Venn diagram. So we're still under theory of sets. So we look at some aspects under set theory. So as I've told you earlier on that so the aspect we're looking at, we are not going into the details of solving some problems, but we are looking at basics, some basic concepts that we need to understand before we can start solving one problem. So part of it is Venn diagram. We just look at it and see what a Venn diagram is. So we can also represent a set using diagrams. So a set can be represented by showing its elements within a boundary. You know, I said elements or members of a set are all those that are contained in that set. For example, mathematical set, all the materials you have inside the set is what the element of that set. For example, in the class, what those things, items you have in the class are the elements of that set. So that is it. So these can also be represented in a circle. So when you have a set being represented in a circle like this, for example, you have set A. If set A includes all the elements, it's 1, 2, 3, 4, 5. And you now put everything in 1, 2, 3, 4, 5. This is a Venn diagram. Now we're still going to look at the complex type. So if you have another B, set B, and which is what? 2, 4, 6, right? So you can see that this is set A. Set B, there are some elements we have in set A and we also have them in set B. So this means that if you want to draw the circle of B, it's going to overlap on what? On A. So that we're going to have another one this way. So this is B. What are those things that you have in A and you also have in B? So we have 2 in A, we also have 2 in B to be here, where they are intersecting, where they are what? Overlapping. Then we have 4 in A, we also have 4 in B. So we also have this one here. So this will be 3 here. Then we have 2, 4, then 6 here. So this is set B. So this is one of Venn diagram. Then we also have the other one. If we're still going to look at that aspect, which is universal set. So universal set will now be represented in the rectangle. So the universal set is a set. That's what the next thing we're going to look at. Universal set. Universal set. So when you talk about universal set is a set that contains other sets that if you have a problem, universal set is one that will contain everything. For example, universal set, all the elements in universal set will be the elements that contain everything we have in other sets, and some other that are not here, that are not in this set, will also be included in what? Universal set. I hope that is very clear. So for you now to represent the universal set using Venn diagram, it will be in the rectangular form. So all these one will now be put inside, be embedded in what? In the rectangle. So this will be what? The universal set. So universal set has now it has its own symbol. So the symbol of the universal set is either you make use of this or you make use of something like it. So this is either you see this or you see this. This all refers to as universal set, and that will be written on this side. This universal set, or you have this way universal set. I hope that is very clear. So if as you list all the elements here, and we have 1, 3, 4, 5, 2, 4, 6. We can have some other element outside like this. Have some other element outside here. Right, you can see. So which means universal set here for this particular problem will be everything you have inside this. That is from 1, 2, 3, 4 to 10. As you can see, everything here. So some are in A, and why some are in B. Why some are neither in A nor in what? B. Because those are the ones we have outside the circles. So this all refers to as what? Venn diagram. We are still going to look at how to solve problems on this kind of Venn diagram. So that's what we're going to look at in this video. We are still looking at all the basic things that you need to understand under set theory. So move to the next one. Move on. Don't forget, in our last video we talked about subset and superset. Now, which means that set A is a subset of what? Universal set. How is it? Also, B is a subset of what? Of universal set. How is it? Meaning that universal set is a superset of A, and universal set is also what? A superset of what? Of B. You understand? So that's what I want you to understand. So we'll be going back and forth all those terms so that you don't forget them and you'll be able to know how to apply them by the time we start solving problems. So let's look at another aspect of this. Before we look at set builder notations, we notice something here. This is repeated twice. That's missing from right. So this one is the same thing. So we are not expected to repeat an element twice. It depends. Unless from the set given, if 4 is repeated twice, then that's when you can have it here. So but we have only 1 4, right? So you must have it and they are intercepting at this place. So I hope that's very clear. Then we want to look at set builder notation. So you see this aspect is very, very important. You need to pay attention here. Now, because by the time we start solving the problem, you'll be seeing something strange here. And that's what I want to explain under what this set builder notation. So when a set of specific a set specified by using, when you have a set that is specified by using algebraic expression, so that is such as something like this. You have something like this. This is what we call set builder notation. So we're going to look at how are we going to have it. So when you have something like this, when set is written this way, so what does it mean? So that's what we want to look at. Now, a set that is written P equals to X colon X less than equals to what? 5. How do we read this? Also be written this way, X slash X less than equals to 5. What does it mean? So this colon means such that. The colon you have there means such that. That's the interpretation. So it's telling us that X such that X is less than equals to what? 5. Then we are looking at all the values that are less than and also equals to what? 5. So we are saying that P, we want to write out this. Because sometimes they will give it this way. We are going to list out the elements. So the elements of P here, we are, since we have so many numbers that are less than 5, so we cannot write everything. So we just put dots. That is, we have them, they are plenty. So we can start from, let's say, -2, -1, 0, 1, 2, 3, 4, and then what? 5. Because it is also equals to all these numbers from 4 downward are less than 5. But we have equals to here, it means 5 is included. But if there is no equals to here, it means we are going to have 5 here. But because we have equals to, that is why we're going to have 5 here. So this is what we refer to as set builder notation. And this class is also saying the same thing. The same thing as what? Sort that. I hope this is very clear. So that is how to, this is what we refer to as set builder. To look at some examples now. Let's look at other examples that we can have. So for example, we have this Q. We have the first one. How do we list out the elements here? Now we have Q is equal to X such that X squared minus 4X equals to 5. You can see what we have here is quadratic equation, right? So what are we going to do? So we have going to list out the element. So what you expect to do is what? So what to solve this? Find value of X. And now we give you the elements. You know, when you have quadratic equations, when you solve it, you are going to have 2 answers. So which means the elements you are going to have in this set Q will be what? 2 elements. So what we're going to do, we're going to solve it. So X squared minus 4X, this will bring it to this side, that minus 5 equal to what? 0. So when you solve, you can use factorization, we're going to solve this. Alright? So 5, we can have minus 5x. So which means we can have plus 1x times plus 5x. So this will give us minus 5x, and minus 1 plus 5x will give us minus 4x. So we make use of this. That will be x squared minus x plus 5x minus 5 equal to 0. So x is factorize x, that will be x minus 1 plus 5, that will be x minus 1 as well equal to 0. So that means x minus 1 then x plus 5 equal to 0. So therefore, you can have x minus 1 equal to 0 or x plus 5 equal to 0. So that means x is equal to 1 or x equals to what? Minus 5. So this means the elements. So since the value of x is what? 1 or minus 5. So the element in set Q, we can then write that to what? Q equals to what? Minus 5 comma what? 1. That is it. All this is very clear. So you can see that another topic is now coming into what? Section. So no topic is missing. That's what we have done quadratic expression. Even if it's not factorizable, you have other two methods you can use. You can use completing the square method, or you make use of what? Formula method. Almighty formula to solve it to get your answer. How this is very clear. So that is the first example. The second example that we have here, so that one is just an explanation as well. How do you interpret that? How do you list out the elements? When you are given this type of question, you have how. It can be written in two ways. So we have x such that 5 is less than x, less than equal to 10. Then x is and what? Integer. So the same thing. So it's also telling us the same thing here. The z written here is telling us that x is an element of z. Z here is referring to what? Integer. Anywhere you see z in set, z here is talking about what? Integer. We have some other symbols, letters that we use under set as well. These are still going to let you know. So let's now interpret this. 5 is less than x. So if 5 is less than x, so which means x must be more than 5. That is going to the next number after 5 is what? Is 6. And because it's an integer, it has a whole number. So we cannot say 5.1, 5.2. It means we are talking about whole number. That's why this mention it clearly to you that it is an integer, is a whole number. Exactly. So that means the first number you're going to have here is what? 5 is less than x, which means that x is greater than what? 5. And the next whole number that is greater than 5 is 6. So 6 will be here. So we continue writing it, then we now consider, so 6, 7, 8, 9. Then x is now less than equals to 10. So all these numbers are less than 10. So equals to, because we have equals, don't forget what I explained here. Because we have equals to here, there will be what? There will be 10 here again as well. So if we should remove the equals to here, if we should remove it, there won't be what? 10 here. But because of the equals to, we put it. How this is very clear to you. So that is that on this one. So we have other symbol that we have we have z for integer. We have n for natural number. We have w, we make use of w as well. Whole number, same thing. Whole number, right? And we also have q. Q is talking about rational number, right? Then we also have r for real number. All these are very, very important when you are solving sets, problems on sets. So we're going to look at the next aspect of set. So what we are going to look at next, we're looking at number of elements in a set, and that is denoted by name into the set if it is A. All right. For example, you have set A is equal to 1, 2, 3, 4, 5, 7, 9. So number of A. How many elements do we have here? So 1, 2, 3, 4, 5, 6, 7. Equal to 7. That's what the number of elements in the set. Then we have equivalent sets. We have what? Equivalent set as well. Equivalent sets. So two sets are said to be equivalent. Two sets said to be equivalent if they both have the same number of elements, of what elements? You understand? That is, for example, as this one is having 7 as n, the number of elements of set A is 7. So we now have another set B, whose elements are also the number of elements in that set is also what, 7. But we are not saying that they must have the same element. Please get this right. So let me give you an instance. We have A, as we have it here. A is equal to 1, 2, 3, 4, 5, 7, 9. So we now have another set B, which is this. We have 2, 4, 6, 8, 10, 12, 1, 2, 3, 4, 5, 6, and then 14. So you notice that the number of set A is 7. Number of what set B is also what, 7. But the elements we have there are not the same. So we have some elements that are common to both of them, but they are not the same element. But we are saying that the number of elements in each of the set are what we have the same, 7 here, 7 here. But we don't have the same elements here. I hope I'm making sense. So this is what we call that A is equivalent. We write 3 equals to equivalent to what it will be. That's the same one. A is equivalent to what it will be. Then we also have equality of sets. Equality of what? Sets. So they are not the same thing with equivalent sets. So under the difference between the two is just that we are going to have the same elements. If you have 1 here, you must have 1 here. 2 here, 2 here, 3 here, 3 here, 4 here, 4 here, 5 here, 5 here. That means sets A and B are equal. They are the same. For equivalence, they have the same number of elements. For equality, they have the same element. The elements you have in A are the elements you have in what? In B. That's what refers to as equality of what? Set. So we can write that as 2 sets are said to be what? Equal. 2 sets are said to be what? Equal. To be equal if they both have the same element. The same what? Element. That's it. So if A is, we said B is 2, 3, 4, and set Q is 2, 3, 4. So we can say that P is equal to what? Q. This is what we call equality. As I not use 3 lines, I use 3 here for equivalent, and this is equal. P is equal to what? Is equal to what? Q. So if we move to the next one, we're going to be looking at union of sets. Union of sets. Union of sets. Union of sets. So when we talk about union, it's like, so people want to get married, you want to unite them. You want to bring husband and wife together. So the same thing on that sense. So we can unionize sets as well here. Union set is talking about combining 2 or more sets. You want to combine 2 or more sets together in a single set. Are you with me? Just like we have it here. We have this A, we have this B. We can combine them together without repeating an element twice. So we are combining sets, 2 or more sets together without repeating an element twice. Let's say for instance, so 2 sets are said to be, we are going to unite 2 sets when we combine the elements together. For example, we have this set A. Set A is this 1, 2, 3, 4, 5, 7, 9. And set B is this 2, 4, 6, 8, 10, 12, 14. So we now, and the symbol for union is this. It's taken as just like U. So we now have A union B. We want to combine A union B. We want to combine the two of them together. What are we going to do? We are going to write out the element we have in A and the element we have in B without repeating an element twice. So what we're going to, we have one, we don't have one, we repeat, right? We have 2 here, we have 2 here, we just write 4. We have 3 here, we don't have 3 here, we write 3. We have 4, we have 4, we write 4. We have 5, we don't have 5, we write 5. We have 6 here, we don't have, we write 6. 7, we have 8, we have 9, then 10, 11, then 12. We don't have 11, no 11 you can see. So we don't write 11. Since we don't have it in both of them, we write 12. We have 10, we have 10, we have 10. We write 10, 12, and 14. Then we close it. So this is, we have combined the two sets together, A union B. And this can as well be represented on a Venn diagram. You can denote this on the Venn diagram. It's very simple. Very simple. To do this on a Venn diagram is so simple. So they can ask you set A union B. So when you have two sets, it's very easy. When you have two sets, this is set A, this is set B. They are intersecting. So we look for where they have common elements. They have common elements here. They have common elements here, and that's all. So that is 2 and 4, 2 and 4. Then we now write the remaining elements we have in A. We have 1, 3, 5, 7, 9. So 1, 3, 5, 7, 9. The remaining one here 6, 8, 10, 12, 14. So they ask you to shade A union B. So they're asking you to shade all the circles. So we ask you to shade all the circles here. So the shaded part is what? A union what? Union B. I hope that is very clear. So that is a universal set. So the next one we're going to look at intersection of sets. Intersection of sets. Intersection of sets. So under intersection of sets, we are looking at the elements we have in, when you are looking at the elements that is common, or the elements that are common to 2 or more sets. Elements, please be careful with my words. The elements that are common to 2 or more sets are the what? The intersect of that set. And usually we use this symbol to represent intersect. Something like N. Intersection where they are meeting. For example, let's make use of this. A, want to write A, is set A intersection B is where A is intersecting, where we have elements common to both sets, which is 2 and 4. So 2 and 4 is what? Is where the two sets are what? Have the same common element, have the same element. So that can also be represented in the Venn diagram this way. We have this. This is A, this is B. So this is where they are intersecting. We have common elements. So that is intersection of 2 sets. Then this will lead us to the next one, which is almost similar. So we have very careful. Difference of sets. Difference of sets. So when we're talking about difference of sets, for example, the difference of set P and Q, denoted by P minus Q. So don't forget this, look at this note, denoted by P minus Q. It is set of members which only belong to P but not belong to what? Q. That means that P minus Q is equal to X, such that X is an element of P and X is not an element of what? Q. So how do we do that? Let's look at this example to understand it better. We have P to be this, we have Q to be this. So we are now saying P minus Q. What will be the value? So what we're going to look at is that you will notice that we have 2 in Q as well. We have 6 in both of them. So, but the only element that we have in P that we don't have in Q are just 2, 4 and 8. That means P minus Q is what? 4, 8. So also Q minus P. The only elements we have in Q that are not in what? In P are 1 and what? 5. So that means P minus Q minus P will be what? 1 and 5. So what we are saying in essence is that when you are saying P minus Q, just remove the element that you can find in Q. Remove it from P. The remaining you have left will be what? The value of what? P minus what? Q. Then Q minus P is that you are removing the elements you can find in P from Q. Whatever you have left is the value of what? Q minus what? P. I hope this is very clear. So that is what refers to as difference of what? Set. Then we also have another one, complements of set. And that is where we're going to stop in this video because the video length is getting longer. Complement of a set. So complement of a set looks like this, but not directly like this. So complement of a set, we are comparing a set with the universal set we treated earlier. So we are looking at the elements we have in the universal set that are not in that set we are looking at. Let's say, for example, we have universal sets E to be this 1, 2, 3, 4, 5 to 10. We now have set A, which is this 2, 3, 4, 6, 8, 10, 9, 10. And complement of a set, we have 2 symbols that we use. Either you use something like apostrophe or use C, small c at the top. So we want to find A complement at the top of A like it just has small c like this. Or you have it A apostrophe. We are still saying the same. This is for complement of A. So what we are saying, they have to list the element of A complement or complement of A. The same thing. We are comparing it with the universal set. So that's why we are saying that the elements you have in the universal set that are not in what? In this set A. So we got the complement of A here now. So we are going to look at the elements we have in the universal set that are not in the what? In the set we are considering. So in this case, we have 2 here, we have 2 here. 3 here, we have 3 here. 4 here, we have 4 here. 6 here, we have 6 here. 7 here, we have 7 here. 8 here, we have 8 here. 9 here, 9 here. We have 10 here, we don't have 10. So we are not going to look at the universal set. The one that we have not ticked be our answer. So that will be 1 and 5 and 10. I hope this is very clear. So that is that on complement of a set. This is where we're going to stop with this video. If you find this video useful and helpful, don't forget to give us a very big thumbs up. And if you are new to this channel, don't forget to subscribe and make sure you turn on your notification bell. So anytime I release video, that is able to have access to it. We are going to meet in our next video. Bye for now.